Welcome to The Explainer. So if you're a software developer right now, or maybe you're studying to become one, you've probably been feeling a little bit of whiplash lately. I mean, it seems like every single time you open your feed, there's some new headline screaming about AI writing entire applications completely from scratch. But today, we're going to totally reframe this conversation. We're looking at what we call the iceberg concept of coding. Think of it like this. Right now, the surface level tasks, that's the ice sitting above the water, they're melting away. They're getting automated. But that deep, structural, underwater work, that is absolutely here to stay. And honestly, it's becoming more valuable than ever.
Okay, let's dive into this because it's probably the most common, anxiety-inducing question floating around the tech world today. Is AI going to replace software engineers? Like, is the era of human coding just over? Are we literally just moving toward this vibe coding thing where you just describe what you want and boom, an AI builds the whole thing? To figure this out, we're drawing on insights from an absolute legend in the industry, Anders Hejlsberg. He's a technical fellow at Microsoft and the literal creator of the C# and TypeScript programming languages. With his decades of architectural experience, he has a really clear, incredibly grounded perspective on exactly where human engineers fit into this whole AI-dominated landscape.
When you really look at it, you can pretty clearly separate the hype from reality here. On one hand, AI is unbelievably good at vibe coding, right? Spitting out to-do list apps, writing endless boilerplate, or generating pull request tests. And why is that? Well, because AI is trained on massive data sets. It has seen literally a gazillion basic web apps in its training data, so it can easily riff on them. But on the flip side, AI is definitely not going to design the next generation of CPUs or write a core operating system from scratch. When it comes down to deep business logic, or say figuring out how to shard a database so a specific startup can actually scale, that requires fundamental design and real human innovation.
So think about your daily developer workload as a pie chart. What we're seeing is that the grunt work slice of that pie is shrinking rapidly. AI is acting as this incredible accelerant. It's actively removing those rote tasks like writing standard boilerplate or generating basic unit tests, stuff that honestly developers really shouldn't be wasting their time on anyway. By handing all those mundane chores off to AI, it dramatically expands your capacity for creative problem solving and innovation. AI isn't taking your job, it's taking your chores. And that frees you up to focus entirely on the fun stuff, the architectural and creative side of software design.
Anders Hejlsberg really hit the nail on the head with this. He says, AI is not going to innovate. Someone has to get the right idea and devise the right data structure. It's so true. AI is fantastic at synthesis and prediction, but it doesn't have shower thoughts, right? It's not going to suddenly have this massive breakthrough idea while it's driving to work. AI basically assumes the existence of the complex code and frameworks that it uses to generate its answers. But someone, a human engineer, still has to actually devise those right data structures in the first place.
Let's move to and see how this builds, because looking at the past shows us exactly what human innovation actually looks like in practice. Back in 1996, the programming world was kind of split. You had Visual Basic, which was incredibly easy to build apps in, and then you had C++, which offered massive expressiveness and performance, but was, let's be honest, pretty hard to master. Then, in the year 2000, C# was released to bridge that exact gap. Fast forward to about 15 years ago, and we see the genesis of TypeScript, which was really born out of a desperate need to fix JavaScript's inability to scale for massive modern browser apps. These weren't just automated, push-button fixes. These were fundamental, human-led architectural shifts.
If we look a little closer at that C# milestone, the specific design motivation was to basically create the best of both worlds, giving developers the power and expressiveness of C++, combined with the ease of use of Visual Basic. To actually pull that off, the creators had to look deeply at developer pain points and invent completely new architectural paradigms. For example, C# brought first-class treatment to properties and events right out of the box, which was something developers were manually wrestling with in other object-oriented languages at the time. AI could never have invented C#. It took genuine human empathy for the developer experience to architect a solution like that.
And we see that exact same human ingenuity in the creation of TypeScript. So the Outlook team at Microsoft was building these enormous browser apps in JavaScript, but the language severely lacked scalability. It actually got so bad that they were trying to write their app in C# and cross-compile it to JavaScript, which is pretty crazy. The human innovation here was realizing that if they just added a static type system directly to JavaScript, they could effectively fix it. And doing so unlocked massive productivity tooling. Think about the statement completion, code navigation, and those incredibly helpful red squigglies you see when you make an error in VS Code. All of that came from this human-led breakthrough.
So the crucial point is understanding the fundamental difference between two key concepts, semantics versus syntax. I like to call this the veneer analogy. If you're a beginner, it is so easy to obsess over syntax, the specific keywords, the brackets, the surface-level rules of a particular language. But as Hejlsberg points out, syntax is just a veneer. What you actually need to master are the semantics. That's the deep underlying meaning and logic of the code. Once you deeply grasp the semantics, picking up a completely new language is basically trivial because you're thinking in abstract architecture, not just memorizing a bunch of keywords. And that brings us to the non-negotiable, underwater concepts that every developer absolutely must master. These are the deep semantics. You need to intimately understand variables, arrays, how pointers actually work in memory, and the mechanics of efficient data structures. For example, you shouldn't just know how to use a hash table. You need to understand exactly why it works, how it stores data under the hood, and how to make it more efficient. And definitely add system architecture to that list as well. Understanding these fundamentals dictates the performance of your software. And honestly, this is exactly where your true value as a human engineer lies.
Now, you might be wondering, how do you actually get this deep knowledge? Well, while you can absolutely be self-taught, a structured education or a computer science degree is incredibly valuable because it acts as a massive time saver. By systematically learning the history of programming, how operating systems are built, and the foundational principles of databases, you basically avoid reinventing the wheel. It acts as a shortcut, accelerating your journey past that superficial syntax layer straight into the deep architectural mastery that AI simply cannot replicate. So, if you want to take action on this today, here is your roadmap. Don't just follow along with basic to-do app tutorials anymore. Go out and write open source code. Publish your projects openly on GitHub because that public footprint basically becomes your modern resume. But take it a step further. Try building a custom framework or even your own collection class from scratch. Test the efficiency of different data structures. Getting your hands dirty with those underlying mechanics is literally the fastest way to move from a surface-level coder to a deeply valuable, indispensable software engineer. I want to leave you with this final, provocative thought. Yes, AI can write code, but who's going to make the AI? Who's going to design the operating systems, the CPUs, and the complex frameworks that the AI actually targets and relies upon to function? The answer is you. It's time to stop panicking about these surface-level ice melting and start diving deep into the fundamentals. If you master the architecture and truly understand the semantics, you won't just survive the AI era, you're going to be the one building it. Thanks so much for joining me on this explainer, and keep building.